Hello everyone, welcome back to a new tutorial. In this particular video we are going to cover a new distribution which is a uniform distribution. So actually uniform distribution is a very basic type of your distribution. Okay, so actually uniform means equally likely. This uniform says equally likely. So for equally likely to understand, let's take one example. Let's take you have a dice. So actually a dice is having what? 6 sides. Okay, so whenever you throw a dice, you get a value which is between nothing but your 1 to 6. Okay, so all these values between 1 to 6, okay, are equally likely to come. So this is what uniform distribution says, that the term which is equally likely. So let's take one more example. If you talk about a marks of a student, let's say there are 50 students, okay, and they had given exam, and the marks of a student will not follow in uniform distribution, because the reason is every student is not going to get 100 marks. Okay, so there is not having the same probability of getting 100 marks. So this is something or different case, but in this case of your dice, when you talk about, these are all the number are equally likely to come. So when you take another example, let's say when you have a coin toss, so coin is having two sides, one is a head and one is tail. So if you toss a coin, you are getting a head or you getting a tail. So which is equally likely to come. So this is also a uniform distribution, but this is not a uniform distribution. Okay, so these are all the agenda. So uniform distribution is basically are in two types. First one is nothing but your continuous uniform distribution, and second one is discrete uniform distribution. This is the thing. Okay, so actually when what does this continuous mean? So whenever you are rolling a dice, you will get a value like 1 2 3 4 5 6. Okay, this is nothing but your discrete. So we will not going to get, when you will throw a dice, you will not going to get a value like 5.5 5.4 4.5 2.5. okay, you are not going to take such dice. So continuous uniform distribution is, let's say if you are creating a sample value which is nothing but 0 to 1, so you will get 0.5 0 point something called 1 or 0 point something like you are going to get. Okay, this is all about the continuous and discrete. Okay, and I had talked in the previous video about the why we need a probability distribution in that particular section. So actually uniform distribution is purely random. All other distributions are affected by some other factors. Let's say when I talk about Poisson distribution, when I talk about geometric distribution, when I talk about exponential distribution, which I had already taught over on the YouTube, you can watch it if you did not watch. Okay, these all other distributions are get affected by some of your factors. Okay, let's see some of the code related to your uniform distribution. So actually these are all are the library which I need to import. So this library is very important, we need to import here. Through this we will implement distribution. In this uniform distribution is available. Okay, so these are all things. Let's go. So basically the idea is I want a random variable. I want a random variable which follows uniform distribution. Okay, this is the thing, and it will have a two parameter a comma b. Okay, and this random variable will follow uniform distribution, which is having some minimum value and maximum value, and I will create some numbers. Okay, so this is the basic idea. So for that I created one thing which is un. This is nothing but, let's take uniform, this is a random variable. So now we retain a stats dot uniform. Okay, this is uniform distribution. RVS means to generate the random variable. This loc1 this is nothing but your minimum value. This is nothing but your minimum value, and this scale, this is nothing but your maximum value. So basically this random variable having a 2 parameter, which is location, loc is equal to 1, scale is equal to 10. So in this it will going to generate a number between 1 to 10 of size 10,000. Of size 10,000 it is going to generate. So basically you will get the first, second, third, and see here dot 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 is available. So basically most numbers are hidden here, and then this one. Okay, these all are 1000 numbers. So what we will do, so overall when I summarize this, so basically x will follow, this random variable will follow a uniform distribution having minimum value which is 1 and maximum value which is 10. Okay, and the value will not go beyond this. So these are all things which I shown you here. Okay, now let's go further. What is the thing? Now I want to plot a histogram. I want to plot a histogram. So for that we will we need to write a particular code, and the code is nothing but let's say I will write sns dot hist plot, sns dot hist plot, and we will pass that variable. So you will get this histogram. Okay, so basically you can see this is the frequency. Okay, this is the frequency count. So you can see almost similar, and this is also called the PDF, probability density function. I will come here. Okay, so actually as you can see, but this is not a straight line, this is going here, someone here, here. But to get a straight line exactly, you need something to put a sign which is called I will show you. To get exactly you need a size which is to be infinity, then you will get the straight line, exactly a straight line. Okay, this is all about the things. Okay, so now one more thing I will show you. You can see here this is called the beans. Okay, this is called the beans. These all are beans. Okay, these all are beans. So when we increase the beans, here, see, I had increased the beans from something default value to 50. Okay, so when you will increase the beans, there will be the variation in a probability. Okay, there will be some variations in the probability. So these all are thing. Okay, one more thing I will show you here in this. You can see this is the PDF of that uniform continuous distribution. So this line is straight, but in that case it was not following the straight line. So this was not following the straight line. So what is that you need to do is increase the size to infinity, then you will get this line. So this is the assumption, but in the reality it is different. Okay, this is all thing. So what we had done, with some random variable which is following uniform distribution, and we passed the two variable. These all are agenda. Yeah, so let's say what we had done, put a is equal to 1 and b is equal to 10 we had put in the code. So actually this is a is equal to 1, b is equal to 10. So I want something, a probability of getting minus 10 or 0. I want, so you will see the probability, it will become a 0. It will become a 0. Why? Because see, density, actually that was in the graph, it was showing count, but it is not a count. You need to change it to density. I will talk about that. Okay, let's say here. So for the density to minus 10 to 0 or 0, let's take minus 20, let's say minus 30 is nothing but it means 0. But when you come, let's take into the range, this is a, this is, let's take, this is the range. Okay, so once you come into the range of a comma b, then you have the value. Similarly, when you go beyond this b, again there can't be anything, you will get the value 0. So you can see these all things. Okay, so this is, you can see all things. This is the thing. So when you are beyond A, you are getting 0. When you are going beyond B, you are getting 0. Okay, so whenever you come into the range, you are getting exactly value. This is all the thing. Okay, so whenever you plot a histogram, you are going to get this PDF. Okay, this PDF you are going to get, and the area which you are seeing here, this will always be 1. This will always be 1. This will be thing. And let's take one more thing. Let's talk, if this length is B minus A, if this length is what, B minus A, then this height is going to be your 1 upon B minus A. For example, if it is being 1 and it is being 100, then your B minus A value will become what, 100 minus 1, and height will become 1 upon 100 minus 1, which is nothing but 1 over 99. So values between 1 to 100 and density for every value, like let's say 20, is going to be 1 over 99. This is the thing. Okay, so I will show you. Yeah, you need to change, actually here I had shown your stat was by default it was cont, but you can change to density, and this gives you actually density. Y-axis gives you actually the density. This is the thing. So whenever you need a PDF, so this is the PDF. This is the PDF of this what we had plot between 1 to 10, and this area which is here you are showing is saying this is nothing but your 1, and this is nothing but your B minus A, and this is nothing but height is 1 upon B minus A. This is all the thing. Okay, this is all the thing. Now we need to talk about the CDF. We need to talk about the CDF which is donated by f of x. Okay, when we talk about the CDF, so actually we write CDF like this type. Okay, it means probability of a random variable x can take values smaller than any or equal to any arbitrary values. So actually this random variable, this is nothing but your values, and this is nothing but your random variable. Let's assume we are talking about the 1000 values. Let's talk about, we are talking about the 1000 values. So the probability of getting the random variable, yeah, so probability of this random variable taking value less than or equal to 20, less than or equal to 20. So this is what CDF is. So CDF says what is the probability of random variable taking less than or equal to arbitrary number. This is all about the CDF. So when we talk about the CDF, so CDF definition will remain same for all the types of distribution. Okay, so when you look at the CDF, here, what is the probability that a random variable takes value less than or equal to minus 10? That is nothing but 0. That is nothing but 0. So actually probability is 0. So actually value is starting from 1 and it is going to something called 100. Is going to something called 100. So before A it is 0. Before A it is 0. Now let's talk about what is the probability for getting a value less than or equal to 200. It is going to be 1, because probability of getting value below 200 is nothing but your 100%. So all values is between what? All value is between 1 to 100 and it is less than 200. So you are getting value 1. Now you can see between A to B, between this A to B. Okay, At 100 you can see the probability is 1. This will show you the probability 0 and 1. At between here you can see the probability is going to be nothing but your 1, because probability of x is less than equal to is 100. This is what CDF is. So actually y axis, this y axis will give you the probability that is 0 and 1, and in the case of the PDF it is going to give you the probability density function. Okay, so this is all about the thing. So when I when we see here the code, I will show you. Yeah, this is the density. Yes, I want a PDF between of -10 between 1 and a scale is 100. It is going to get 0.00, but when I put 20 you are getting 0.19. So in that case we are going to the from NumPy we created a -40, 140 and 1. This is all the things. So number has been created from -40 to 140 having gap 1. This is all thing. So you can see this is all created. Now I want a CD. Now the main thing is I want to plot the CDF for this. I want to plot a CDF for this. So we will write a code CDF. Let's take, we created one variable which is of nothing but CDF uniform, and we pass the here. In case of PDF we write the CDF, and this is x which we created here, location is 1 and 100. Now this is the CDF. This is giving you the probability between 0 to 1. This is giving you the probability which is nothing but your 0 to 1. This is the case all about for this CDF graph. Okay, so actually when I talk about this 0.1, this is nothing but you're giving the your for the PDF, this is nothing but yes, for this is nothing but giving you the density. Okay, so this is all about your the PDF and the CDF. Now next thing is when we talk about the discrete. So in case of PDF, in the instead of PDF you are getting the PMF, because you can't have a value like 5.5, 4.2, 3.2 like this type. So you will get a value like 1, 2, 3, 4 and 5. Okay, all these values have the same probability which is nothing but 1 by n, and this n is nothing but b minus a plus 1. This is what n. Okay, so for that this you can get, let's take a is nothing but your 1 and b is nothing but your 5. So you are getting 5 minus 1 plus 1 you will get 5, and this is what the CDF looks like. Okay, so for the CDF, let's take, I am going to calculate for the -10 you will get 0, 0, 0, 0, 0 something. For the CDF of 100 you will get the value like 1. For the CDF of 2, let's take, what exactly CDF of 2 means. Okay, what exactly CDF of 2 means, yeah, this is what. So you will get probability of x is equal to 1 plus probability of x is equal to 2. So probability of getting value 1 and 2, because x can take a value 1 and 2. Okay, so this is what discrete. In discrete we do the summation. Okay, we do the summation because it is discrete. Okay, in the case of continuous we will do the integration from here to here. This is all about the uniform distribution, and you had seen all the code part related to it, to this. Okay, this is all the PDF and CDF. Here is warning, that's why I had used KD, but you can look at the warning here and you can check it out. So you, yeah, by clicking here. Okay, I will paste all these things in the description box as well. Thanks for watching this video.